This is a Rohde Schwarz audio frequency signal generator designed to produce very clean audio outputs that are very stable from 1 Hz to 260 kHz. Bought as a spares or repair. It's not working, and I'll go into that in just a minute. The idea of this is I've had quite a few inquiries about people making them stable audio tones for their setting the speed on their cassette decks, and I've already sold a couple of tapes already, but I have been using the Philips generators you see here, and it works fairly well, but it does drift about a bit, and it's constantly having to keep it in check to make sure it's not drifting in frequency. So I thought I'd try and buy a synthesized generator that will lock to the frequency and be nice and stable, and that's the idea of this Rohde Schwarz. But as I say, it was sold for spares or repair, and the seller said he powered it up and it looked like it worked okay, which basically meant he wasn't sure, and then he went on to say but he hadn't done any testing on it, which basically meant he plugged it in, he saw a light come up on it, so he assumed it worked. Well, anyway, the fact of the matter is it doesn't work, and that was sort of what I was expecting. You always think you may be lucky and you get something that will work when the person doesn't actually know what he's doing, but this chap sells electronics all the time, so he obviously knows what's working and what isn't. What it was doing, at the moment it's in bits, but what it was doing was on power up, all you got was the readout on the parameter here and the level reference here for the impedance matching, and the only thing I could control was with the variation control knob here, and that would allow me to adjust the attenuator inside, and you could hear all the relays buzzing away, and that's all it would do. There was no control over the keyboard at all. So it was stuck in continuous mode with this LED on and this LED on here, which is the attenuator adjustment, or the matching adjustment, should I say. So okay, so I thought, well, I'll take the front panel off and check for any sort of obvious damage inside, and I couldn't see anything at all. So the next step was to try and track down what was going wrong with it. Now, if you light through here, I don't know if you can see just behind this metal shield, you probably can't see it actually, but just behind this metal shield here is the keyboard connector, and this the keyboard connectors go joins up to these little C277, C282. They are just between there. You see these solder points here. They are wires, and they go from that connector up to this chip that was in here. Now this chip is this chip here that I've just pulled out of it. Now this is the if it's going to focus, this is the it's a parallel interface IC. And as I can't get a manual, as for normal with Rohde Schwarz, you can't find manuals for these, so you have to sort of, if I'd known, I should have looked for a manual first off before I bought it, to be honest with you, but you can't find manuals for it. But anyway, what I have tracked it down to doing is, there's various bus points on this chip, and these first 4 or 5 pins are connected to the keyboard, and if you press the individual buttons, you'll see these points go high and low in logic. And whichever button you press, there's about six bits wide, so whichever one you press, one goes high, one goes low, or one goes low, one goes high, and there's always a different variety of how it's set, you know, so it's that part's working fine, and that's fed into the chip, and then that chip is supposed to send the data out to the central processing unit, which is this point here. Now, it's from looking on a scope, whatever I did to that input of that chip, nothing changed on the output. It was exactly the same all the time. So what I did was I've cut the chip out. The chip was soldered in. I've put a header socket in here, so I've cut the chip out, and that's the easiest way to do it. You cut all the legs individually, and this means that you can get the chip out without damaging the plated through holes on the circuit board. So I've cut all the legs off it and removed the chip, and I've got another chip coming. Hopefully it will turn up tomorrow. Now, it's a bit of a gamble. I'm not sure that's going to fix it. It certainly seems to me that that chip is actually doing nothing at all. And then from there, if we don't get any luck there, it's going to be something on the control. The generator was actually producing an output. although I couldn't do any adjustment on it, it was producing a decent sine wave output. So the generator's working, it's just the central processor unit isn't interfacing with the VCOs. So basically the keyboard's not telling the VCO what to do, or telling the CPU or via the CPU what to do to the oscillator output. So basically the basic thing is working. This chip here is a RAM chip. I can't really see that being a problem, and it's also got battery backup. I have removed the battery backup battery that you see here, and that's the purpose of that is to try and clear any sort of corrupted data in this chip, but that made no difference at all. This is your EEPROM here. I'm hoping I'm hoping that's fine, because if that's not fine, it's going to be a big problem trying to track down a ROM map for this, as Rohde Schwarz stuff is so elusive on the internet. There's no information at all on stuff like this. All these little chips here are little like flip-flops and sort of logic gates and NAND gates. They're all readily available on the internet from a company called Little Diode that I use, and they're very local to me, so I get the delivery within a couple of days. And they're excellent service. They always seem to send genuine good quality components, so that's good. So I should be able to sort of almost shotgun this thing to get the thing to work. Hopefully, that's my plan. Power supply wise, everything looks in really good nick. The power supply's caps, none of them are swollen. I checked the voltage on the output here. These little linear regulators, everything seemed fine. The one thing that is a bit of a shame with this signal generator, it's got a fan in the back, and you can see I've taken the fan out to clean it. And that obviously sucks all the air through the unit, and the unit was quite dusty when I got it. Now, looking round, I can't see anything in here that will require cooling other than the TO220 regulators. So what I might end up doing is actually seeing if I can get it to work, to make a heatsink that will bolt on the back of this to keep it cool, and then maybe run it for a couple of hours and just have a look in with a thermal imaging camera just to see if anything's getting too hot. But most of this stuff will run at sort of 40-50 degrees. This is actually an output transformer, a high sort of quality audio quality output transformer, and that was the advantage with the APN-62. Apparently there was a lesser model that didn't have that output transformer. That's supposed to give you better spread of frequencies, or better frequency response or something. I don't really know, to be honest with you. I haven't really gone into it that far. There's a couple of pots inside here you see for adjusting the voltages, but as I say, nothing needed touching here. You've got a couple of calibration points here for adjusting various things. This board here on this enclosure here on the side is purely a square wave generator, and that's fed out from the socket here, the square wave socket here, should you need to produce a square wave, and that was working as well when it was producing output, so that's no problem there. So what I'll do is, hopefully tomorrow, I'll run through this with you on the video and show you what I'm doing, but tomorrow I'll get it up and running, and maybe we'll see something working. Thanks for watching.